Amos Tversky and Thomas Gilovich, in their study on hot land in basketball, found that in a random sample of games, Larry Bird hit a second free throw in 48 of 53 attempts after the first free throw was missed, and hit a second free throw in 251 of 285 attempts after the first free throw was made. Is there sufficient evidence to say that the probability that Bird will make a second free throw is different depending on whether or not he made the first free throw? Conditions for inference. We have two independent SRSs of free throws made following the first free throw. In order to determine that the population proportions are approximately normal, we take N1 P hat 1, N1 Q hat 1, N2 P hat 2, and N2 Q hat 2, and as long as all of them are greater than 5, which they are, we can assume that the sampling proportions are approximately normal. And so since N1 P1, N1 Q hat 1, N2 P hat 2, and N2 Q hat 2 are all greater than or equal to 5, we can assume that both sampling distributions are approximately normal. And the third condition for inference is we assume that N1 is greater than or equal to 10 times the sampling size of proportion 1, which equals 530. And we assume that N2 is greater than or equal 10 times the size of the sampling size of proportion 2, or 2,850, and this assumes independence.
For H0, we have P1 equals P2, and for HA, we have P1 is not equal to P2, where P1 is the true proportion of second free throws made after he misses the first free throw, and where P2 is the true proportion of the second free throw made after missing the first free throw.
Alright, so next we have our calculations. First we're going to get our Z score using our test statistic, and that equals P1 hat minus P2 hat, all minus P1 minus P2, which equals 0, over the square root of P hat times Q hat times the square root of 1 over N1 plus 1 over N2. We're also going to calculate our P hat value, which equals X1 plus X2 over N1 plus N2. So let's do our P hat value first, and we get a 0.885, and we're going to use that in our test statistic value. So we're going to take 48 over 53, or first proportion, minus 251 over 285 minus 0. Then we're going to take that P hat value, which is 0.885, and then we're going to multiply it by 1 minus P hat, which is 0.115, and we're going to multiply that value by 1 over 53, which is our N1, plus 1 over 285, which is our N2, and our Z score is 0.552. Then we're going to get our P value, which, since it's a two-tailed test, we're going to multiply it by 2 to get 0.602, and that's the probability of Z being greater than 0.552.
And for our conclusion, the first step, since p-value of 0.602 is greater than alpha of 0.05, we fail to reject H0. And for the second statement, there is not sufficient evidence to suggest that the probability that Bird will make a second free throw is different depending on whether or not he made the first free throw.
A pollster wants to determine the difference between the proportions of high-income voters and low-income voters who support a decrease in the capital gains tax. If the answer must be known to within plus or minus 0.2 at the 95% confidence level and the sample sizes are identical, what samples should be taken? For the calculations, we're going to use M equals Z star of the 95% confidence interval times the square root of P1 hat Q1 hat over N1 plus P2 hat Q2 hat over N2. 0.2 equals 1.960 times the square root of 0.5 times 0.5 over N1 plus 0.5 times 0.5 over N2. 0.102 is equal to the square root of 0.5 over N. 0.0104 is equal to 0.5 over N, and N equals 48.077. We always need to round up in these situations, so N finally equals 49.